Right, okay, so we're going to look at hypotheses and theories. Let's move that on. Now look at the nature of scientific proof. Talk about hypotheses with an example of hygiene hypothesis. We'll start to talk a little bit in general terms about hypothesis testing and statistical significance, though this will be done more in the Excel exercises. And we'll wrap up by talking about the normal distribution, which again will link through eventually to statistical significance. Okay, so scientific proof. You often see claims in the media that science has proved or disproved some particular proposition. Don't pay any attention to them. Pythagoras' theorem or Euclidean geometry are proofs based on logical arguments that demonstrate unambiguously that the proposition is correct. Mathematical proofs are final. End of argument. Science is different. Reality is complex. Our understanding is developing continually. For example, we can't measure everything, and the measurements we make are necessarily imprecise. So the current scientific view on any topic is based on the available evidence, but our view may be altered by further and better evidence. So science is tentative. A couple of concepts here which we'll talk about again later in the course. Causal inference is the process of drawing conclusions about a causal connection based on how conditions influence the occurrence of an effect, which is sort of a complicated way of looking at cause and effect. It's often very difficult in the circumstances we talk about to clearly establish a link between cause and effect in people and in human populations. This is especially difficult with individuals who vary widely, so the best measurements we do are carried out at population levels. So we don't say that cause leads directly to effect. We say certain conditions may be associated in a causal inference way with an effect. And there's another definition there, etiology, why things happen. Okay, Albert St. George is a key figure in understanding vitamins. While investigating Addison's disease, he extracted several substances from the adrenal glands, including vitamin C. He's also very quotable. Addison's disease, if you haven't heard of it, is a long-term endocrine disorder in which the adrenal glands do not produce enough steroid hormones, which is what he was looking at. He actually discovered vitamin C and elucidated its chemical structure by accident. Here's another vitamin, vitamin D. It's a key micronutrient. The active form is vitamin D3, which is synthesized in the body by a complex biochemical pathway. It includes the action of UV radiation in sunlight and cholesterol. We'll talk about vitamins and minerals more in semester 2. I mentioned cholesterol. Despite its bad reputation, cholesterol is an essential nutrient, and we synthesize about 80% of our body, 80% of it ourselves, the rest coming from food. In some cases, people may produce too much of it, and it precipitates out as gallstones, which can be very painful. The scale here is in inches. Okay, the roles of vitamin D. This is the most well-known nutritional issue with suboptimal amounts of vitamin D, bone health. Both in children and adults, it causes weakened bones, particularly in older adults, and in children it can cause bones to bend, and shown in the skeleton here. Rickets was first identified in populations that had migrated from the country or the coast into rapidly developing cities. So in the country, and particularly the coast, they got lots of sunshine, they got lots of fish. Migrating to the city produced significant changes in diet, less time spent outside. Also, pollution obscuring the sun was probably a significant issue. So a very different environment. Fish oil was found to prevent rickets and was given to children right up to the 1970s in this country. This report from 2016 recommended the government considers strategies to help the UK population consume the recommended intakes of vitamin D. As we'll discover, vitamin D has more roles than just bone health. In the real news recently, we have seen potential links between vitamin D levels and preventing or treating COVID-19. However, as recent as 2020, last year, the National Institute for Health and Care Excellence, NICE, and SACN, the Scientific Advisory Committee on Nutrition, both said there was no evidence to support taking vitamin D supplements to prevent this. Obviously, again, evidence is developing. The BMJ review here suggests there may be some protective effect against acute respiratory tract infection, which is often associated with people with serious infections from COVID-19. So the evidence is developing. Again, if you're interested, you can click on these images and they'll take you through the various links. Okay, so the key issue in understanding developing collecting the evidence. This is a key issue in developing our understanding of evidence around the impact of micronutrients on health. Index diseases tend to be short latency, that is, they quickly become obvious in the event of nutritional deficiency, so rickets for example. Can usually be treated by application of the particular missing micronutrient. The non-index diseases, conversely, take much longer to produce clear symptoms, maybe decades. They're said to have a long latency. Vitamin D in COVID may be somewhere in between, and having adequate amounts of vitamin D is, however, a very good thing generally. So that's the final word, irrespective of COVID-19. This mind map summarises well-established and potential roles of vitamin D. So we talked about the index diseases. It does seem to be associated with a range of longer-term issues, including many associated with diseases associated with the immune system, multiple sclerosis, inflammatory bowel disease, maybe food allergies and cancer as well, and possibly coronavirus. And there's a picture of the active form of vitamin D. Okay, so hypotheses, just to start thinking about the main topic here. It's just a theory is a phrase often used by people who wish to disparage or actively undermine science. With respect, their understanding is faulty. Theories develop from rigorously collected sets of observations that have been verified, it says varied in English, that should be verified, multiple times by qualified researchers. So gravity is a theory for which there is a superabundance of evidence, so much so that it is often referred to as the law of gravity. If you roll your pencil off the desk, it falls down. Always. But before there's a theory, there's a hypothesis. In some cases, hypotheses are based on a body of evidence that needs to be understood further before it can be established as a theory. Our understanding of the index diseases associated with suboptimal vitamin D intake is perhaps of this status. There are other hypotheses that seek to answer questions and provide a framework for the investigation of an issue in science. One example of this is the hygiene hypothesis. This was developed by Strachan first in 1989. It proposed that the rise of childhood allergic conditions such as asthma is linked to increased levels of hygiene in childhood.